For this video, we will be multiplying and dividing fractions and mixed numbers. To begin, let's write an equivalent fraction for each one of these, for number 1 and number 2. So I will do number 1, and then I will ask you to pause the video so that you can work on number 2. So let's begin with number 1. We have 3/4. So I'm going to draw a bar to represent these 3/4. So I have my bar. And I'm going to take it and I'm going to split it into 4 equal parts because that's what my denominator tells me. There should be 4 equal parts. Sorry about that. And of those 4 equal parts, 3 should be shaded in. So I'm going to come in and I'm going to shade in 3/4 because each one represents 1/4 of the whole bar. So this is 1/4. This is another 1/4. So now I have 2/4. And here's another 1/4 for a total of 1, 2, 3/4. We want a fraction that is equivalent to 3/4, meaning it has the same value. So I'm going to take these and I'm just going to split them into smaller pieces. I'm not changing the value. I'm just breaking it down into smaller pieces. So instead of fourths, I'm going to go and take all of these fourths and break them into 2 equal parts. So when I do that, I see that my total now is 1, 2, 3, 4, 5, 6, 7, 8 equal pieces. And our denominator represents all of the equal parts, which was 8. And of those 8 equal parts, let's see how many are shaded. 1, 2, 3, 4, 5, 6. So there are 6/8 shaded. So an equivalent fraction for 3/4 would be 6/8. And equivalent fractions can go on forever. So this is just an example of how to come up with one equivalent fraction. At this time, go ahead, pause the video and attempt number 2, 13/25. Now that you have had an opportunity, hopefully you were able to get a fraction. If you used the previous method, we would take it and have a total of 50 equal parts. And of those 50 equal parts, 26 would be shaded in. And we know this because if we look at our previous one, we took everything and broke it into 2 equal parts. So if I do that, I can see 4 times 2 is 8, 3 times 2 is 6. So same thing here. 2 equal parts. We broke each one 2 times. So if we look at that previous one, we can see that. And we'd have 26/50. This would also work if we decided to break this into 3 equal parts. Then we would have still an equivalent fraction. There would be 75 equal pieces because all of these would be broken into 3 equal parts. So 25 times 3 is 75. And then I'm going to take the 13 that's shaded, and they each should have 3 equal parts for 39, because 13 times 3 is 39. Let's go through and simplify each fraction. So I'll do this first one, and then I'm going to ask for you to pause the video and try the next one. So for here, we have 10 out of 20. That is representing a total of 12 pieces. And of those 12 equal pieces, 10 should be shaded in. So I'm going to erase my board from previously, and I'm going to bring in 12 pieces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So you'll see those there. So I have a total of 12 pieces. Now I want to represent this with shaded. So I know I should have a total of 12 pieces. So that's my total. And of those 12, I'm going to use red for my shaded. So of the red, of the 12, 10 should be shaded. Well, right now I have a total of 12. I can't go over 12. So I'm going to start exchanging. So for this 1/12, I'm going to take it out and exchange it for 1 red. I'm going to take out this 12th and I'm going to exchange it for another red. And I'm going to continue to do this until I have 10 red. And the reason why I'm taking this one at a time is because I'm going to go back and count to make sure that I have the correct amount. And if at any time I get mistaken, I've gone over, I just get confused, I can literally stop and count to see if I have a total of 12 pieces. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I still have my 12 pieces. I'm going to make sure 10 of them are red because that's what we said we're going to use for our color. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I had to do one more exchange. And before I go on to do that problem, that looks kind of orange. I'm going to make sure that I have a total of 12 pieces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have a total of 12 pieces. Of those 12 pieces, 10 are red, which leaves me with 2 blue, meaning they're not shaded. So my goal, I have all of these grouped together. My goal is to make this a group so that I have the same amount in each group and they look exactly the same. For instance, I have one big group with 12 spaces and 10 of them are shaded. I'm going to try to make a group that's equivalent, but it looks more simple. What do I mean? Well, I see right now I can make possibly 2 groups. One group that has a blue and another group that has a blue. I couldn't make 3 groups because I only have 2 blues. So now let's try with these reds and see if we can go and simplify those into these smaller groups. So 1 here, 1 for you, 1 for you, 1 for you. 1 here in this group, another in that group. Here's 1 in that group, here's 1 in this group. So it looks like it might work. And so now I'm going to look to see, do these groups look exactly alike? Let's see. This first group has 1, 2, 3, 4, 5, 6. Let's see if the second group has 6 as well because they have to be equal groups. 1, 2, 3, 4, 5, 6. Okay, total of 6. So that means so far our denominator would be 6 for this group and 6 for this group. And we know this because the denominator represents the total in that group. So now let's see how many are shaded or how many are red, because remember we said the red represents the shaded. So looking here in this group, I have 1, 2, 3, 4, 5 that are shaded. And in the second group, I have 1, 2, 3, 4, 5 that are also shaded. So as I look at this, I can see that they are indeed equivalent fractions. 5/6 is equal to 5/6. So I know that 10 over 12 or 10/12, 10 out of 12, also has the equivalent value in simple form of 5/6. And how did I know this was possible? Well, I took my 12 total pieces and I split them into 2 equal groups. So when I took 12 and I split it into 2 equal groups, I was able to get a total of 6 in each group. When I took my 10 shaded and I split those into 2 equal groups, I can see that a total of 5 red were there as well. I could not make any more groups that were smaller than this because I only had 2 that were non-shaded. So either I was going to have these together in one group or see if I can separate them into 2 groups. With that, go ahead and pause the video and try number 4. So looking at number 4, if we take our method from before, we could definitely split this into 2 equal groups. And we know this because they are both even numbers, and even numbers are divisible by 2. So if I have 78 and I split that into 2 equal groups, then I am going to have 39 for our shaded. If I have a total of 100 that can fit there and I split that into 2 equal groups, then I will have 50 for my total. Let's go ahead and now look at these as multiplying and dividing fractions. Our first example that we're going to work on is number 5. And number 5, what are we going to do? We have 2/3 of 9. So when we see this word of, that is our math indicator of multiplication. So this is saying 2/3 times 9. Now let's see, what is our 9? Well, I'm going to take this total. In fact, I'm going to, instead of using these pieces here, I don't want to confuse you. I am going to come through and show you with the board. So what do I mean that? 2/3 of 9. We're going to begin with a total of 9. This whole bar represents 9. And we want 2/3 of it. So that means we need to take this total of 9, split it into 3 equal groups because that's what our denominator tells us. And we only want 2 of those 3 equal groups. Well, let's see how much goes in each group. So if I have 9 and I split it into 3 equal groups, I'm going to even pull out those tiles so we can see. 2, 4, 6, 8, and 9. So we have our 9 pieces, and we want to put them into 3 equal groups. So here's one group, here's a second group, here's a third group. And all of these groups look exactly alike. I have 3, 6, 9 for total. Looking at it, I put 1, 2, 3 in this group, 1, 2, 3 in this second group, 1, 2, 3 in the third group, which means every one of these equal groups has a value of 3. So now if I only want 2 of those 3 groups, I can see that I would have a total of 6. And we see that here with the bar model. 3 plus 3 is 6. So therefore, 2/3 of 9 is equal to 6. Go ahead, pause the video, and please attempt, and I'm going to move all of this so it's not in your way. Please go ahead and attempt number 6, where you're going to do 3/4 of 16. Pause the video and try 3/4 of 16. Well, now that you've had an opportunity to try 3/4 of 16, let's go ahead and check it. 3/4 of 16 means our whole bar has a value of 16. And we want 3/4 of it, which means we're going to take 16 and split it into 4 equal groups because that's what the denominator tells us to do. Split into 4 equal groups. So we want to know how much would be in each group. We would take 16, split it into 4 equal groups, and get 4 in each of these groups. When we add these together, it will give us our total of 16. Now, we only want 3 of these 4 groups. So 1, 2, 3 of the 4 equal groups. Let's see how much that is. 4 plus 4 is 8. 8 plus 4 is 12. So 3/4 of 16, sorry, you couldn't see that. 3/4 of 16 is equal to 12. Let's go ahead and move on to our next one. So 3/5 of 25, go ahead, pause the video and try that. 3/5 of 25. So we are going to do the same thing here. We're going to take our whole of 25. And we are going to split this into 5 equal groups. And we only want 3 of those 5 equal groups. Let's now look at number 8. Number 8 is saying 1/2 of 48. So we are going to take 48, which is our whole, represents our whole bar. And we only want half of that 48, which means we're going to take this whole bar, split it into 2 equal groups, and we only want 1 of those equal groups. Now, let's move on to our next problem. This is where you will go through and you can practice this. The great thing about it is that you have space to show your work for each one, especially using that bar model. So now let's talk about still finding a part of the whole, but this time we're going to be using a fraction greater than 1, or an improper fraction, fractions that are equal to or greater than 1. So let's start off with our first example, 3/2 of 12. So we are going to take our whole, which is 12, and we are going to split this into 2 equal groups. So I see that there's one group here and our second group here, and we're doing 2 equal groups because that's what our denominator states. So that means for this 12, in this group, it would be 6. And our next group, it would also be 6. So we are looking for 3/2. That means we only have 2 groups, but each group has a value of 6. So what if we're getting just one group? One group would give us 6 because one group has 6 in there. What if we wanted a second group? Well, that second group, and this is total, let me indicate that. One group total would be 6. If you add another group, you're going to add another 6 for that second group for a total of 12. Well, if we go back to the question, they're asking for 3 of those halves. So we need to do a third group. So a third group would be 18. How do we know that this is going to work? Well, this is a great time to switch to the algorithm, meaning the way that we would do this abstract if we had the actual problem written out. So 3/2 of 12. Well, 3/2 is written as a fraction. Of means to multiply. And 12 written as a fraction. Since it's a whole number, we write whole numbers over the number 1. So great thing about multiplying fractions is that once you have it set up to where they're both fractions, you're going to take the numerator and multiply across. So 3 times 12 is 36. You're then going to take the denominator and multiply across. 2 times 1 is 2. Well, hopefully you remember how to simplify, because this 36 over 2 can be simplified. They're both even numbers, so I know that we can simplify by dividing the denominator by 2 and the numerator by 2, because this is an equation. And equations are equal. They're fair. Whatever you do on one side, you do to the other. Whatever you do for the numerator, you must do the same for the denominator to keep it fair, to keep it equal. So 36 split into 2 equal groups will give me 18 in those groups. And 2 divided by 2, 18 shaded, and 2 divided by 2 is 1. Now, if you remember from what we did earlier, we write whole numbers over 1. So we put the whole as our numerator, and we divide it by the denominator of 1. Well, looking here, I see that I have 18 as the numerator and 1 as the denominator, which lets me know whenever there's a 1 in the denominator, the numerator represents our whole. So therefore, 3/2 of 12 is 18, just like our figure from earlier. So to make sure that you are seeing this connection, I'm actually going to go back to the problems that we worked on earlier. And in these problems, I'm going to, instead of doing the actual model, I'm going to go through and I'm going to show you with the algorithm. So for this one, we have 2/3 of 9, which is the same as saying 2/3, and of is multiplying. 9, we write that as a fraction. Since it's a whole number, we put it over the number 1. The number 1 is our denominator. Now we're going to multiply straight across. 2 times 9 for our numerator will be 18. 3 times 1 for our denominator is 3. And if I take a total of 18 and I split it up into 3 equal groups, let's look at what I mean by that. Well, if I have one group of 3, that's going to be 3. If I have 2 groups of 3, then that's 6. If I have 3 groups of 3, that is 9. 4 groups of 3 is 12, because each time I'm adding 3 for every group. 5 groups of 3 is 15. And 6 groups of 3 is 18. And if you look, we were taking 18 and putting it into 3 equal groups. If I take 6 groups of 3, I get 18. So if I take 18 and I split that into groups of 3, I'm going to end up with 6. So 18 over 3 is 6. And let me bring that model back in just for you to see the relationship. I'll put the model right here in this corner. So remember, our whole is 9. And we're taking that 9 and we're splitting it into 3 equal groups, because that's what our denominator tells us. So when we take 9 and split it into 3 equal groups, we get 3 in each of those groups. We only want 2 of the 3 equal groups. We only want 2 of the 3 equal groups. So if I take those 2 equal groups and I put them together, I get a total of 6, which matches our algorithm.